majority element, although it is marked as an easy, but it can be very medium for you considering if you don't know its optimal solution. So please watch it entirely. We will discuss 5 ways to solve it. Just a disclaimer that we will discuss all the 5 ways, although there are technically more than 5 ways, but those extra 2 ways are actually very worse and you should not think about them. 5 ways are more than sufficient. Now, starting off with the problem is very simple. It says that you are given an array nums of a size n and you have to return the majority element. Now, the simple meaning of majority element is any element which is occurring more than, again, it is not more than equal to, it is more than n by 2 times, that element is considered as the majority element. And the problem focuses and says specifically that you will for sure find the majority element in this specific array. This can be a very big thing because in interview you have to ask the interviewer, sir, are we sure that majority element will for sure exist in the array or not? If not, then what else to return? Now, as you can see with the simple example, we can just see, because see, majority element is some element which is occurring more than n by 2 times. So we can just simply count the occurrence of element. Okay, 3 is occurring 2 times and we can see 2 is more than my 3 by 2. 3 by 2 is nothing but 1. Again, it's a floor value. So for sure 3 is a majority element. So answer is 3. Same way for the next array, my majority element is 2 because its frequency, it is occurring 4 times. So I can simply say that it is more than my 7 by 2. 7 is the number of elements, which is 7 by 2 is 3. So I can simply say, now very obviously the first brute force approach which you might have thought of is, I'll simply, Aryan, you have said that, okay, you will simply know the occurrence of the element. This occurrence as in, okay, frequency of the element. So for sure, I'll use an unordered map or a hash map, and then I can just get the frequency of the element. That is true, but you have to go way brute force. Now, a brute force worse than this approach also is nothing but you specifically do a pathetic brute force. What the pathetic brute force means is that if you are standing on to an element, you will consider that as a prime element. Okay, I am standing on the element I. Then I'll go on and check, okay, for that nums of I, what is the frequency in this entire array. Okay, if that is more than n by 2, simply return that right then and there. If not, then go on to next element I. Then again, go on and check in the entire array, what is the frequency of that element. Again, if that is not also, okay, next element. Again, go and check in the entire array, what is the frequency of that element. It is, although you might see, Aryan, what rubbish is this? But yeah, it is brute force. So that is one way that you will go on to every element, and as you land onto an element, let's say nums of I have, I'll go and find the frequency of that element, nums of I, this entire array again, to just know what is the frequency of that element. And the same way I can just do it for other array. Now, Aryan, why have you made such a big array? For this simple example, you will get to know later on. But now let's see the code. It's pretty simple. Again, I know you would not be able to think this because it is more hard to think this brute force approach rather than optimal approach. But yeah, still, just so that you can tell 5 follow-ups to an interviewer, that's the reason I just told you. So you can simply go on to all the elements. Now for the current element, I will go on and check that element's count for that num. I'll go and check that count of that specific num. If it is more than the majority count is nothing but n by 2. If it is more than n by 2, then I can simply return my num, which is the specific element. Else I can keep on trying for all the elements. So I can simply see it is O of n square and no space is used, so it is O of 1. But for sure, the obvious approach which we thought of in the very beginning is we can just simply know the occurrence of the element. So I can simply use my hash map or an unordered map. I'll go on to my all the elements. I'll go and check the frequency of those elements. Okay, frequency, and okay, you can simply keep on iterating on the elements. Okay, I'll iterate on 2, then 2, and then as I encounter an element, I'll keep on increasing its frequency. 2's frequency is 4, 1's frequency is 3, and so on and so forth. Now, same way for this element, frequency 7 is 10, frequency of 6 is 5, frequency of 1 is 1. Now I can iterate on this entire frequency unordered map, and then any of the values, because unordered map is a key value pair. So any of the values, if it is more than my n by 2, n by 2, n by 2, then I can simply return and say that key is actually the element which is occurring more than n by 2 times, right? So it will be a simplest approach. So we see that we will just simply, again, everything remains same exactly. We just simply have a frequency map, unordered map. Again, for the folks who want the code in Java, you can just simply go on ChatGPT or BART and convert that, or now Gemini. Now, so we can simply go and keep track of the frequency of all the elements and increase the frequency. As soon as it is done, I'll go and again iterate on my frequency map. I know it's a key value pair. Value is nothing but the frequency itself. So if the frequency is more than the majority count, which is nothing but n by 2, then I can simply return that key, because that key itself, again, it will never go here, because the problem itself says that you always have the majority element. But in the interview, you have to put this condition, considering what the interviewer asks you to return if you don't have the majority element. Now, as you can see, for sure, I will have O of n time, because I'm iterating on all the elements, and O of n is for sure the minimum time you will have to take. Space is the thing, because you are using an unordered map, and in the worst case, you can store all the n elements in this unordered map. So that's the reason space is O of n. Now, interviewer will ask you, I don't want this space which you are using right now. Although in the previous approach, you used O of 1 space, but then your time was very high. And then your time was low, very low, but your space is now very high. Can you please optimize it? Now, you will think of, okay, one way is bring something between that, between O of n square and space O of 1, and between O of n and space O of n. How I can do that? Simply, I can simply say that time I will get it to O of n log n, and space I can maybe get it to O of log n, or maybe O of 1. It is kind of a midway I am trying to reach. So whenever O of n log n or something like that comes in, simple sorting can come in picture. Again, it is also hard to think a next follow-up as sorting. Next follow-up, people directly reach on to something else. I'll tell you what something else, but yeah. Next follow-up, we can just simply imagine that, okay, we have to optimize the time. So maybe we can just apply sorting and stuff, which means, okay, I just want to get the time to O of n log n, or reduce the space to maybe from O of n to reduce it. Now reducing as in it can directly reach to O of 1, or it can reach to O of log n. So, and I know in sorting my space uses O of log n itself. So maybe I can just sort it down. But how sorting will help me? Ultimately, remember the aim. मकसद नहीं बोलना है. Aim was that you want the frequency of the element more than n by 2. Now you want the frequency of element more than n by 2. If I plan to sort these elements, or basically if I just say that if something has a frequency more than n by 2, so let's take an example. Always take some examples to actually dry run, or basically see how things are performing. So let's take, I took an example, empty, my n is 5 and I have some elements. I have some 5 elements. Now, if I say that I can sort, I know something like that, and then I want from that, can I figure out that who is the majority element, as in who is more than n by 2. Now for this n equal to 5, more than n by 2, as in the element should have at least a frequency of 3, which means that element will be occurring 3 times or more, but I'll take the least possible. I'll take only 3 times. Let's imagine it is occurring only 3 times, which is at the brim it is occurring. So if it is occurring at least, it is occurring 3 times at least, which means let's take the brim 3 times. So what will happen is that, and again, it is sorted. So every element will occur consecutively. Every repeated element will occur consecutively. So this X says repeated element. So that's the reason I have represented my X as a pink color. Other elements, I'm not sure if they're repeating or not, matching with this element X or not, no worries. But that X is actually repeating. So let's plot the possible places where this X, again remember this X is occurring 3 times. So now plot that, okay, if I have this X 3 times, what all places it can occur. And I know I have sorted it, so they will occur consecutively. So one way is X occurs right here, other way is X occurs right here, and last way is X occurs right here. So these are the 3 possible ways only X can occur. That's it. You can easily see that X is always occurring on this n by 2 location. Now it is for sure always true. Why is that the case? Because I know that my maximum frequency element, which means the element which I having the maximum frequency, it is specifically said it is more than by n by 2. So it is more than from n by 2. So if one thing is for sure, that okay, n by 2 is this number of element, right? Half elements more than, which means okay, it will for sure be occurring in the mid. Now it is the worst possible case. Edge cases are the worst possible case, which means if the something is at the super end, let's erase this. If something is at the super end, again, if something is in the mid, then for sure he can come in mid. The maximum frequency element can come in mid. But if something is in the super start or in the super end, then always, even if it is in the start or super end, still it will be occurring in the middle element, because I know that this is the n by 2 number of elements, but I am saying I will have more than n by 2. So for sure he will have to come at the mid location, and that's the reason the mid location will have the maximum frequency element. And thus I can simply say that I'll simply sort my elements down and I can simply return my mid, which is n by 2 position element from nums, and that will be my answer. Again, here we have always found the answer. If you don't, like if the interviewer says that you may or may not have the answer, then after sorting, let's say you have got this element which is nums of n by 2, then get this element and again go and get the count of that element. If it is more than n by 2, then you can simply return. If again, I'll just simply, again, considering the interviewer asks that maybe the majority element is not even there in the array, then you will get this element, let's name it as element, then you will iterate on the entire array, let's name it as ME, majority element. Right. So I'll just iterate on the entire array for element in nums. I'll go and count. If element is equals to a majority element, simply increase the count plus. Now if the count is more than my n by 2, then simply return your majority element, else return your answer, return your -1. This condition you will have to add considering you don't have the majority element, but right now we have, so we can simply return this. Again, this condition will follow everywhere in the future also in the code wherever you don't find majority element. So now you can simply see that the time will be O of n log n because of sorting, and space will be O of log n. For C++ and Java, for Python it is O of n. Now again, if I ask you to optimize it, one way you can think in the bit manipulation terms, because see, bit manipulation just at top of the normal approach, bit manipulation help us saying, okay, right now my complexity is O of n log n, right? I know one thing for sure, that in an integer I have log 32 bits. Sorry, log of integer is 199 number of bits. So I know, again, it's a base 2, so that will be nothing but 32 at max. So I know one thing, that I can convert this time to O of n log c. Again, c is less than my n. C is, again, like c is more, but this value can be less. It might seem, but it is actually constant, and it can actually replace that by 32. You might end up saying Aryan O of n log n is less than, no worries, hold on, but space is also used, right? Space is also used. So because of using a bit manipulation, again, bit manipulation is same way saying that you have to count the frequency of elements. Now rather than counting the actual elements, you will count their bit frequencies, which means that considering right now I have my nums as 3, 2, 3. Again, how you thought of that, you have to go in that direction, because using bit manipulations, although you will use a n log c, again c, which is the constant factor, which means your nums of I value, it is actually 1e9, which is more than your 5 into 1e4. So n log n, log of n would give you 20 bits, but log of 1e9 will give you 32 bits. So it's kind of increased, but still, because of bit manipulation, you can use a constant space. So you are actually optimizing the space and increasing a tiny little bit. So that's the reason I will now, again, my aim is still fixed. I will go and get the frequency of the elements, but now I will use bits. So I'll go and get the frequency of the bits itself, which means if I have this specific array, I know I want to get the maximum frequency element. Now, if let's say I go and reverse engineer, so I know right now the maximum frequency element is 3. So if I bifurcate that into its binary representation, which is 1 and 1, I would simply know that okay, it is coming as 1 and 1, which is the maximum majority element, right? Which is 3. It is coming as 1 1 maximum majority element. Now, if it is coming like this, so one thing is for sure that one bit, this 0th bit would have occurred majority number of times. This first bit also would have occurred majority number of times. So earlier I was counting this 3 as if it was in majority or not. Now I will count its corresponding bit if it is in majority or not. Now, if it is not in majority, if let's say if the number would have been a 2, let's imagine if the number would have been a 2. So let's imagine if the number would have been a 2. Let's say 2, 3, 2, something like that. So majority number should have been something like 1 0. So I would have said that okay, if this element, if the 0th bit, if it is not a majority, please don't consider that. One bit is in majority, so please consider that. Let's understand with an example. So let's take the very back example. We have a 3 2 3. Now I will go and check, okay, what is the 0th bit frequency, 0th bit count. I'll go and check the 0th bit count. 0th bit count, it came out to be a 2, which is for sure more than n by 2. So my 0th bit will contribute in my majority element, and that 0th bit will actually be contributing in my majority element 0th bit. Again, for the first bit, again I'll go on and keep on doing it for all the 32 bits, because I know the number is 1e9, so I will have 32 bits in that. For the first bit, again I'll go on all the numbers and check their first bit. Again, if you have not seen or known how to check the bits, go and write on YouTube bit manipulation playlist by Aryan Mittal. You will get a playlist in which we discuss that okay, if we have to go and check in a number that if the first bit is set or not, then we simply go and do a first bit, which means this specific bit, simply do a left shift, one left shift by the number of bits. Here I just want to know that first bit is set or not, so one left shift by 1 1, which means okay, first bit I want to check, that value will give me something like 1 0, and then I'll do an AND operation with my original number to know if that specific first bit, which means if the, let's say if x bit was set or not. So simply one left shift x. Now just do an AND operation with the original number to know if that x bit is set or not in the original number. If that is the case, I can simply say okay, it is true, which means that first bit was set, simply increase the count. Okay, here also it is set, increase the count. So count is 3, which is more than my mi2. So for sure my first bit will also contribute in my majority element as an answer, and whosoever is contributing in my answer, just simply keep on adding in my answer that bit, which means if in my majority element, initially my majority element is 0, but I know the 0th bit is contributing, so I know that this majority element is becoming something like okay, the 0th bit is set, then the first bit is set. Simply keep on building the answer because of that specific bit. And how to build the answer? Simply do a OR operation. That is how I extract the bit by using AND operation and build the answer by using the OR operation. So I'll go and iterate again. I know I have 32 bits. I'll go and try for all the bits starting from the 0th bit. Now I'll grab what is actually the bit in the, as in this bit is the mask which I am making to grab out the ith bit from my nums. So I'll get the bit count. I know from my nums I have the current element as num. In my nums I'll do AND with my mask which I have got it above, if that is not equal to 0, which means for sure that bit was set, that bit ith bit was set, and I can increase the count. And for sure, if ultimately after increasing the count, if the count reaches beyond n by 2, I can simply say for sure that the majority element will have that ith bit as set. Ith bit as set, which means the mask of that ith bit would actually contribute to my answer. I can simply use that mask itself, to put that specific bit as set in my majority element. And to make a bit set in your majority element, you can simply use a OR operation. And that's how you can simply build your majority element. So because of this fact, as you can see, this is a log C operation. C is a constant factor, which is 1e9, right? This is a n, O of n operation. So your time complexity is O of n log C. But your space is O of 1 because you are not using any extra space. Now, although this is technically a constant thing, this log C is technically a constant thing, but still, the interviewer might still ask you to optimize it more. Now, to optimize it more, please, although people will name this as Boyer-More voting algorithm, although you should remember that okay, this is a kind of a name which is used in finding the majority element kind of problems. Again, there are two problems, which is majority 1 and majority 2, which means here you have to find the majority element having more than n by 2. There's also a problem which is more than n by 3 kind of. So in both of them, you can just simply use one fact. See, again, forget everything so far if you had known about Boyer-More algorithm. Forget everything. The simple fact is you have to optimize the time to O of n without increasing the space, which means you cannot use any extra space, but still you have to use the time as O of n, and O of n will for sure be used because you have to iterate on all the elements. Now, coming on back, that what I can do, I want the majority element. I want the majority element. So, and again, minority, it doesn't matter for me. Majority element is something which is occurring more number of times, because you're sure majority element is occurring more than n by 2 times. So for sure, it will occur more number of times than that of the minority element. So I can imagine one fact that, okay, whatsoever is the majority element, I can increase and I can do a +1 for the majority element, and for the minority element I'll do a -1, which means, okay, any element which is not a majority element is a minority element. So for that I'll do a -1. Now because of this, if I keep on doing, okay, for majority I'm doing a +1, for minority I'm doing a -1. Now if I keep on doing the sum for it, if I keep on doing a sum for it, then when my sum is 0, when my sum is more than my 0, which means when my sum is positive, that will represent that right now I have majority element in picture, right? If the sum is more than, again, if the sum is more than my 0, then I will represent, I can say that I have majority element in picture with me. But Aryan, one thing, hold on. You said that you have to find the majority element, and right now you are saying that for the majority element you will do a +1, and whosoever is not majority you will do a -1, which means you should be knowing the majority, right? That is the catch here. So I will imagine I don't know the majority. Whosoever is coming first is the majority for me. For example, that if I have this specific input array, right now I am at 2. Again, by default, my majority element was -1, which means I don't know, and the count is 0, which means, again, this count is the sum, this count is the sum, and this count will say the sum, if it's positive, it will just simply say that number of extra majority element I have apart from minority. Now, initially it is 0. So when I'm at the first element, for sure, no one came in earlier. So this is my majority. Again, I never know. My ultimate aim is to use this, but to use this, I never know who is my majority. So whosoever is coming first, I will consider that as my majority. So I'll simply say, okay, right now I don't know who's the majority. So he's coming first. My 2 is coming first. So he's a majority element. Its count is 1. Okay. Next element. Oh, again, 2 is coming first. 2 was actually majority element. Oh, and I remembered, for the majority element, I'll simply do a +1. So I'll do a +1 for majority element, because right now I have considered by default that 2 is the majority element. Okay, then 1 came in. Oh, it is not equal to my 2, so it is a minority. If it is a minority, simply do a -1. Okay, -1. Again, next element 1. Oh, it is not equal to my majority. Simply do a -1. Okay, -1, which is 0. Oh, now my count became a 0. What count equal to 0 means? Count equal to 0 simply means one thing, that you don't have either a majority or a minority. Both are same. Which means, if you, in the very beginning, if you remembered, you started off with the same thing, that you don't know who's the majority. Your majority element value was a -1 and the count was 0. So same way, right now, as my count came back to 0, I can simply default back to their original value, which is -1, 0. Again, it is not required to actually remove that and put a -1 because you can simply override in the next step. But still, for your simplicity, I am just overriding back to a -1 because right now I know I don't have any majority right now. So okay, I can simply say I had no majority right now. Okay, next time 1 came. Oh, 1 came. Great, bro. 1 came. So now 1 is the majority element with the count of 1. Okay, 2 came. 2 is not equal to 1. So simply it is a minority element. Okay, reduce the count to 0. Oh, count is reduced to 0, which means again I don't have any majority element. Okay, great. Simply majority element is -1 again. Again, a 2 came. Oh, 2. Let's imagine this has a majority element. Now the count is increased to 1. Oh, the array has ended. So with this fact, I can simply say the majority element is my 2. But now, majority element, when I say is my 2, it is said that it can be 2. Aryan, why is that case? Because simply imagine one thing. You said majority element is the element. Again, I am saying that 2 is the element which is actually can be a majority element candidate. It can be or cannot be majority element, but Aryan, I can simply see 2 is actually my majority element. But simply if I remove this 2 with the 3, 3, 3. So you can see still because of the algorithm which we took, it will simply say no majority, no minority. Simply this will also say no majority, no minority. But this will say my 2 is actually my majority. But simply you will see the count of 2 is just 1. It is not more than n by 2. So you just have to add other verification again. In this problem, it is always there. So I will not add a verification. But in the interview, you will have to add a verification that if you have got the last majority element, have a quick check. Have a quick check and count its actual frequency in this entire array. That count its actual frequency. If its actual frequency is more than n by 2, you are great and return that majority element. Now, for other example, we will have number 7. Okay, it is a majority element. Count will be 1. Next 7, again same majority element. Count will be 2. 6, minority. Count decreased. 7, majority. Count increased. 6, minority. Count decreased. 1, minority. Count decreased. Oh, count decreased to 0, which means no majority element right now. Okay, 6, majority. Count increased. 7, minority. Count decreased. Again, -1. Now 6, majority. Count increased. 6, majority. Count increased. 7, minority. Count decreased. Another 7, minority. Count decreased. Count decreased to 0, -1. Okay, 7, majority. Count increased. Again 7, majority. Count increased. Again 7, majority. Count increased. Again 7, majority. Count increased. Oh, error ended. Oh, so this can be my majority element. Again, to verify that, I'll again go and check the count of my element 7. Count. Okay, element is equals to my majority. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Count of 7 is 10, and which is more than my n by 2. So it is a majority element. So simply return that. And that's how, again, forget the name of this algorithm, but remember this fact that you just simply want to do a addition. Simply want to do a simple. Okay, add a +1, -1. Majority element +1, other element -1. So as to actually get the majority element. Cool. Code is pretty simple. I will firstly imagine my majority element as -1. Count for that is 0. I'll go on and check if the count is 0. If the count is 0, so whatsoever element is coming in with me will be the majority element. Else, I'll simply say if the current element which is coming in is equal to my majority element, then please do a +1, else do a -1 in my count. Ultimately, I can simply return my majority element because I for sure know. Again, in this, I missed one line which is actually go and checking the count of that majority element in the actual input matrix, because I for sure know that majority element will exist in picture because the problem says. But in the interview, you will have to ask the interviewer this thing, and I can simply return the majority element. Space is O(n), time is O(n), because I'm simply going on to all the elements just once, and that's how I can simply solve it. That's how amazingly we have seen 5 ways to solve it, from very brute force to hash table to sorting to bit manipulation, and then to using a Boyer-More voting algorithm. Cool, thanks so much. Bye bye.